folding. Micro unfolding and macro folding. That means, well, there exists a macro model, then unfold to the micro model, or micro model fold to the macro models. Okay, I'll show my example. Let's consider that infection model, typical type of SIR model. This is the infection as a stock flow dynamics, like a system dynamics. Okay, in that case, S susceptible person, not infected, and the infected person and the removed person, not that we died or recovered. Okay, then this is the famous SIR dynamics, and it will be described by typical type of system dynamics. Okay. But, well, SIR epidemic model is a typical macro dynamics models that consists of a macro 3 variable, SIR. And the SIR macro model assumes the infected person meet every susceptible person randomly. It is idealized model fiction, typical type of fiction. That fiction is included in this formula implicitly. Okay? So the relation of micro model and macro model. So micro model and macro model, we say so aggregation, or in other words, we say folding. And this is a reduction, or agent-based model construction. We say unfolding. So macro model and micro model. And so state transition, dynamical change, and dynamical change. Then, well, these mechanisms should be required in micro model and macro model relation. Okay, so micro model transition and aggregation, or aggregation and transition gives the same result. Okay, anyway, so in our model, SIR model and our infection model, so boundary is specialized. And if we assume the random matching among each agent, then folding, then, well, this, like this macro variable is determined. Then this micro model with macro symbol corresponds to macro dynamics. So this becomes a well similar one. Okay. But, so this is a very simple folding process. Okay, I'll cut on this. But if a unit, anyway, not so difficult one. Okay. The most important point is we give the more realistic boundary condition. Microepidemic model with human activity model, city structure, and so on. Then boundary condition is quite different. Then its dynamics is not correspond to macro model. Okay? This model assumes implicit simple boundary condition. In many cases, in these days, well, macro model is described by differential equation, like, well, that includes the system dynamics. But that kind of differential equation macro model assume a hidden micro boundary condition inside that model. So we unfold that hidden boundary condition and induce micro model. Then we can add different, more detailed or realistic boundary condition on that one. Then the result is quite different from micro model. So that kind of relationship is essential. SIR macro model and microepidemic model in general. Then microepidemic model under the random matching interaction. Then microepidemic model under the random matching interaction with macro variable SIR. Then these macro SIR model and micro model with macro symbol correspond to. Okay, so that relation is okay. But if we add more complex boundary condition, then result is quite different. So no longer macro model can be applied in these type of more complex model. So we focusing on microdynamics. And in many cases, in this stage, so many macro model is used in natural science and social science. Like, I forgot the exact name of equation anyway. Okay. And also, multi-aspect unfolding. That is another important aspect. For constructing a model, we introduce, human activity process model and traffic process model, and also, infection process model, and also, population structure model, and infection process model, and this is a microprocess model. And we can combine these models in one language. So different languages come together. That kind of extension is called multi-aspect unfolding. This is essential to construct that one. This is a quite new domain because, system composition and decomposition, system scientists treat that kind of concept traditionally. But for example, so standard system composition, we use same language, same matrix, and combine the big matrix. Okay, but in this case, language is quite different, but come together and construct a combined model. So that kind of multi-aspect, so unfolding model construction is very, very essential. So, specification and unfolding and specification. Special aspect of model boundary and model language come together, then multi-aspect unfolding. After the multi-aspect unfolding, we construct a combined model. We say multi-aspect unfolding. And also internal and external subjective unfolding is also important, I think. So agent exists. And if we introduce an internal model itself, we add the agent, and we model these processes itself. Then we say internal model unfolding. And also, if we introduce the agent-based modeling and people who are using this model, this process itself are modeled, then we say external unfolding model. And combined, that one is the internal and the external unfolded model. Internal subjective unfolding focus on variety of internal model by inside agent of the models. And external subjective unfolding focus on how model is used by external decision makers. That itself is modeled. So that kind of modeling is very, very important. So simple case of internal subjective unfolding is, for example, in the case of game theory, so hypergame is a typical type of internal subjective unfolded model. So each agent have a different payoff table. And in gaming simulation case, we talk about these simulated gaming simulations, then this is a typical type of external unfolded model. So not epistemology naturalized by Quine or epistemology socialized by Luhmann. We are focusing on epistemology spirally unfolded among a three layers of reality. So mathematical and natural language and simulated language. So social simulation should be designed not for formal scientific verification, but for combining a fragment of knowledge. So social simulation support better communication and the construction of common understanding among the stakeholders of the problem. Okay, now take a short break, and after that, conclusion. Yeah.
I think all of you did about the value of building. I don't know if everybody got that. It's so rich. Showing the different modeling techniques. Maybe Dr. John has some presentation in back to that. Maybe go through it more slowly and then get to the stuff before. So maybe we go back and go through it more slowly. After John is maybe have John send for an hour and a half. I have a question.
Yeah. It's very interesting. And some of the based on the end, we were saying not to design for, I guess, overall model validation. How do you approach validation?
That's an important point. Well, actually, well, scientific validation, well, there are so many concepts. For example, in the area of agent-based modeling, docking is a classical approach of validation. Docking means a different type of simulation gives the same type of result. But in our cases, we are especially focusing on white box approach and communicative approach we are focusing on, and also we are focusing on data validity of data structure. If we used no valid data, like intuitive macro parameter, then model cannot become a robust one. So we are focusing on especially data construction and data structure itself. So, well, anyway, so we'll cut to this one. Okay, but actually, validation is a very, very difficult question. For example, so in the case of game theory, so
Can you rephrase the question?
now,
What is your basic reality test?
basic reality test. Actually, in this stage, there's no horizon because I don't believe experimental economics or that kind of validity test at all. Because at first, give some type of linear model and regression, or then we can discuss some validity. But the basic model is quite different because the boundary condition changes. The model itself has no value. But anytime, in another word, if we have more than 5 parameters, then we can show any types of data. Fit. Yes. So when I was a student, so our professor said, don't give more than 5 parameters. Then I can explain everything in the model. So the concept of validity is a robustness of model, and especially white box approach. I think. Of course, there are some many type of discussion in design.
So I think we'll come back to your presentation
Okay.
after a while.
Okay.
What time is it now?
Okay. So now.
2:10 almost.
Okay.
We were originally going to go to 4.